welcome to this Simactive online training session. My name is François Riendo. I am the photogrammetric workflow specialist here at Simactive. I'm going to be your host for this session about how to generate high-quality orthomosaic with Correlator3D. I'm going to explain today what are the different geometric deformations that you need to correct in raw image in order to get an accurate orthomosaic, with which you can do measurement and include GIS with other mapping layers, and why you need to use a high-end photogrammetric software such as Correlator3D to do this kind of task. So let's start right away. What you will learn today, first I'm going to explain the different types and format of image you can import in Correlator3D. We're going to understand the geometric corrections that need to be done in raw image, choosing between DTM base and true ortho. So I'm going to explain the importance of the elevation model in the orthorectification process. Using an external DEM for orthorectification, it's possible to import your existing DEM from another source. Generating the mosaic from the individual orthos, assessing your mosaic accuracy when it's generated, how you can edit the mosaic seam lines, adjusting the final radiometry, which means the brightness and contrast if you want to adjust this on your image, managing multiple sets of orthos and mosaics in the project, how at the end you can export your final mosaic, and finally we're going to quickly look at creating NDVI maps with images that will have infrared bands, 4 bands. Let's first look at how imagery is stored in the digital world. So a digital image is what we call a raster. It's a regular grid of cells where the smallest unit is called a pixel, and each pixel can store numerical values which may represent, for example, different reflectance that has been captured by your sensor in different spectral bands, for example, red, green, or blue. And these different bands will be displayed through your monitor screen on the same red, green, and blue channels. And that's how you're going to see the image in color on your screen. But actually, it is stored as numerical values, can be stored in 8-bit, meaning that you will have 256 possible values per pixel, or 16-bit, which raises up to 64,000 possible values. And if you have 3 bands, red, green, blue, each band in 8-bit, you will have kind of a 24-bit images and millions of possible values. In Correlator3D, we support 8-bit, 16-bit, and we will keep this information throughout all the process up until the end when you're going to export the mosaic. We won't change the input information that you import in the software. In terms of format, the most common format will be a GeoTIFF, which is a TIFF with a geographic information header to store the position of your image. And we will support obviously the GeoTIFF. We also support a JPEG format and can be compressed or non-compressed. We recommend to process non-compressed images that will be faster. And so these formats are supported in Correlator3D for processing. Understanding the geometric correction is actually what is most important to understand about the orthorectification process. The thing is, as soon as you acquire an image from above, from space, there will necessarily be some deformation in the raw images because of the angle of acquisition, because of the lens that you have used in your sensor, and because of the topography there is. So you need to correct those different geometric deformations. So that's the different sources of distortions that you have in the raw images. Terrain, topography, lens, and angle of acquisition will all include some deformation, some distortion in the raw image. And the process of orthorectification, which is done after the aerial triangulation. So you have already refined the position of your sensor. You know about the geometry of your sensor. And then now you will use a digital elevation model to do the orthorectification and recalculate a new image that will be now in what we call an orthogonal projection, where our perspective ray will be like on a nadir projection, like it would be seeing from above. If you compare here with what is a raw images projection, obviously you have scale problem because of the topography. You have different perspective angle that will create leaning effect on buildings and trees. And so you have also relief displacement. So all these distortion need to be corrected, and that's what is done during the orthorectification to obtain this projection, this type of orthogonal projection with uniform scale and no relief displacement. What will affect the planimetric accuracy of the ortho? Well, obviously, the aerial triangulation process is what will define the accuracy of your resulting product. So everything you're going to generate after the aerial triangulation will depend on the accuracy of your AT of the aerial triangulation. But the elevation model in the case of an ortho is very important and can also affect the planimetric accuracy. So if you have elevation error in your DEM, this is going to translate into a planimetric error into your ortho. So the elevation model is very important in the orthorectification. So I'm going to talk a little bit more about that in a few minutes. So when it's time to do the orthorectification, you might want to choose between using a DTM, so a terrain model, or doing a true ortho, which would mean using a surface model, a DSM. And so what are the different options in Correlator3D? Well, you have both of these options in the software. So you can either do a DTM ortho or you can do a true ortho. Maybe in some other software you don't have that option. In Correlator3D, you can choose between one or the other. What is the basic difference between doing a standard ortho and a true ortho? Well, the DTM ortho, because it's using a terrain model where you won't have any building or trees, will only correct the deformation on the terrain itself. So it will not rectify the building perspective leaning effect or trees. It will only rectify what is on the ground because you're using a terrain model for the orthorectification. So you will have an ortho for everything that is on the ground, but you might still have the buildings looking like this with that perspective effect. In many cases, this can be acceptable, and it depends on your project requirement. Sometimes a DTM ortho will be quite acceptable to do. You don't necessarily mind about having the buildings looking like this, the roads and all the terrain. So if you want to display contours on the ortho, that should be all perfectly rectified. However, if you need to have an ortho will have the buildings looking perfectly from above like this, you will need to do a true ortho. The requirement to get optimal true ortho is not necessarily obvious. Doing a nice true ortho can be a challenge, especially if you're using small sensor at low altitude over very complex type of building structures. This can be very difficult to get a perfectly rectified true ortho where you won't see any kind of artifacts or deformation around the buildings. Like, you have to understand that when you do a true ortho and your input image are have high angles on different objects, well, they will need each pixel will need to be displaced and rectified to obtain that kind of projection. So it's a very intense process in terms of rectification. And if your surface model is not accurate enough, if you're flying at too low altitude, you have a small camera, there's good chance that you're going to see some type of artifact in the true ortho. So this is not a software matter. It's really more kind of a geometric problem that need to be solved. So what we recommend is to fly at a higher altitude and maybe raise the overlap a little bit when it's time to cover dense urban area. And ideally, if you have a highly detailed elevation model that will be coming from a LiDAR source, for example, well, it's time to use it for doing the true ortho, because you probably will have a better result if you have a very dense LiDAR with where everything is very well defined in the model in terms of buildings and structure. So that will be very important to get a good true ortho. In Correlator3D, you can use an external DEM for orthorectification. So it's possible to import a DEM in Correlator3D. So if I'm looking in the software, you can just go in File, Add to Project, and you can add a DEM here. It will support the DEM in TIFF format or ASCII grid, Esri ArcInfo format. So either one of these two formats will be support. Internally, Correlator3D use the SMF format. Sometimes that can be useful to save your DEM in that format. That would be faster, and then you can import later another project in SMF. So you can import from the file menu. You can also go just over there and using that plus icon, you will be able to import a DEM. That can be useful to use an external DEM in Correlator3D, because generating your own DEM is sometimes can be a long process. So if you have an external DEM, you can import in the software. If you have LiDAR in LAS format, you can bring them in the software. However, you will have first to convert your point cloud into a raster DEM, a regular raster DEM in GeoTIFF or ASCII grid before importing in the software. Next, we're going to talk about generating mosaics from individual orthos. It's kind of a two-step process. You need to first do the orthorectification of all the individual images. So after the aerial triangulation and after you generate a DSM or a DTM, or you have imported your external DEM, you select the DEM you want to use for the orthorectification and you go in Module and you click on Orthorectification. If you want to do a true ortho, that's where you're going to specify a DSM base. If you leave it unchecked and you use a DTM, then it's going to be a DTM ortho. So you check the DSM base ortho if you want to do the true ortho. And you can use the default parameters. The resolution will be the optimal resolution calculated from your input raw images and in ground units. So here, for example, I have a 7mm ortho that will be generated. So you process, you're going to generate all the individual orthos first that you can see here on the screen if I'm closing this. So you see these are the different ortho that's been generated. They are not color balanced yet. You can see color difference, and there's no seam lines. They are just stacked on top of each other. Now, if you want to create a mosaic, you want to assemble all of these ortho into one single file, and you want to have it color balanced and seamless, you're going to go here in Module, and you're going to use the Mosaic Creation tool to generate the mosaic. And you have the color balancing option here that you can use to do the color balance. And by processing this, that's how you're going to generate that single, seamless, and color balance images. As you can see, it's very nice here. So this is the process of creating your ortho mosaic. First, you do the ortho, a single ortho, and then you create the mosaic. Now you can disable some images in the process. So if, for example, during the orthorectification, you don't want to orthorectify all the images of your project, could be for different reasons. Let's say you just want to create a subset of your project on a single line, for example. Well, you just have to go in the image menu over there, and you can disable flight lines, or you can also disable single images like that. So this is different than closing them like this from the display. This will not prevent them to be processed. So if you want to remove images from the processing, really what you need to do is disable them like that, either one by one, or you can disable a whole flight line like this. So once you have disabled this, and then if you do the orthorectification, only the images that are enabled will be processed. Once you have generated the ortho, and now you want to create a mosaic, you have again the option to disable some of these ortho from the process of the final mosaic. Again, there could be different reasons for that. Let's say one image is very dark, and you don't want to include that ortho in the mosaic. Anyway, you have enough overlap, so you can just remove one image like this by disabling the image from the process. And then after that, if you run a mosaic, only the enabled image will be processed. There's a last thing I would like to mention about creating the mosaics. There's a color balance process that is done. So the software is going to put different sample points all around, all over a mosaic, and we'll use these samples to calculate different statistics, and in a goal to do a color adjustment on the different single ortho in order to create a color balance mosaic. In some situation, you could have very dark area or very, let's say, very high contrast area, and that could affect the color balance in some way. So it's possible to exclude area from the color balance. You can use a polygon that you could go, for example, in the DEM editing module, just to use that module to draw a polygon on an area, for example, just here, for example. And you can save that polygon into an exclusion. And when it's time to create the mosaic, here you have the option to use an exclusion area for the color balance. So that means by using that exclusion here that there will be no sample or statistic that will be created inside that area. So in most cases you won't need to do that. The color balance is very optimized and efficient for all kind of different situations. Maybe in more difficult area where you have a lot of water, and that on the different picture you have different reflectance in the water, that might confuse the color balance, and it might be better in that case to exclude the water body from the color adjustment, from the color balance. So once the mosaic is created, you might want to assess its accuracy. And if you want to validate with your ground control points or checkpoints, it's very easy in the software because everything is in the same environment. So you just have to display the ground control points, and after the mosaic is created, they will be overlaid on the resulting mosaic. So you just have to zoom in on a point and see how good it's matching with its original target. So here in the example, I have a 0.5, and you can see it's very good. And like this, I can browse and pan into a mosaic and look for the other point. Here I have a checkpoints. You can see by the different icons, and it's looking very good. So like that, I can go into all the points and make sure that everything is matching. The mosaic is accurate compared to my ground control points. Another thing you might want to validate after the mosaic is created is its radiometric quality. So how good the color balance and contrast and brightness are. So it's maybe a little more subjective. So the best way is to probably pan into the mosaic and try to look for any apparent seam lines or color problem that there might be. So if you zoom, I will look at the dark and the bright space, make sure there's no saturation, so everything is good. So if you're not happy with the contrast and brightness, in a few minutes I'm going to show you how you can change that in the software using the tools, the color adjustment tools that there is in the software. Another thing also that that will be good to validate, and this is a very great tool in Correlator3D, is that you can edit the mosaic seam lines. So first, a few words about the structure of these seam line files. So the seam line is created during the mosaic process by Correlator3D and use an internal structure to store all the polygons and all the information that need to be stored regarding the different images that each polygon is associated with. So it's kind of very complex structure with a specific topology in terms of polygons and lines, and for this reason it cannot be imported from a shapefile. For example, you would say, okay, I create some seam file manually, can I import them in Correlator3D? Unfortunately, no, the seam lines need to be created by Correlator3D. However, you can export that seam line into an external source, but you cannot edit it in another software. So if you want to edit the seam lines, you have to do this in the environment of Correlator3D. So I'm going to show you a little bit about how it works. So when you have your mosaic created, you're going to go in mosaic editing, and you're going to select the block. In case of a small mosaic, you might just have one block. You select the block you want to edit, and you select here this option to start seam line editing, and the different seam lines are going to display. And then it's very easy, you just have to left click on the line, and you will have the option to move delete points or redraw a part of a line to change how the seam line is drawing. So you can just edit all the point like this, and once you're done, you save the change and you can automatically reapply the modification in your mosaic, and it's very fast. So very easy to go into your mosaic and do a quality check and pan like this, and if you're not happy with a seam line, quickly change its location, save it, and reapply the modification on the mosaic. So very powerful tools. In a matter of few minutes you can just change a few things that are not good. Usually the seam line algorithm is very good to already, you know, go in places where it will not be apparent, but if you are in a very dense urban area, that might need some a little bit of addition, and that way that's really how you can get a very higher quality product to deliver to your customer. So because you have this option to edit all the seam line within Correlator3D. Once it's done, you save this, and then you can just export the mosaic with the apply change. Here I'm how to export the seam lines. That's another thing I might want to show you. That's very easy. You just go into the process. You just have to go into your block first. And then you can go and export the seam lines like this. It's going to create a shapefile. That's how you can export the seam lines. Next is if you want to adjust the final radiometry or contrast and brightness of your image. So just a few words about how to work with histograms, because first let me just go here. If you want to adjust the contrast here, you're going to go in process and color adjustment, and you're going to have these tools that is displaying the histogram of the image. So an histogram will show the frequency of each pixel values, so from the minimum to maximum. So let's say we have an 8-bit image, so on the left that will be 0 up to 255 values. So here it's going to be dark value, mid value, and high brightness value. So there's two things you might want to look at. Is you have the gamma that you can play with, and the contrast will be adjusted with these brackets over here. So as you can see here, the histogram is quite well distributed in terms of value. That's already a nice looking images, but maybe you want to put it a little more in the center, so like this, to have a more equal distribution. And then if you want to get higher contrast, you will use these brackets here, and then you can just stretch the histogram like this from the original location up to the min-max like this, and you will see the resulting image that you can preview back and forth like this. So then it's a matter, I think, of taste and what you want to have. If you want to have a more bright and highly contrasted image, you might want to stretch even more like this, but you have to be careful, because at some point you might saturate the black and the white values if you go too strong, so things are going to turn very white or very dark. You can see now here, so you have to keep things a bit conservative for that. And brightness will be changed by using the gamma like this, if you want something darker or brighter. So once you process and you apply your resulting change, be careful, because it will permanently update the mosaic. So maybe you want to make a backup before doing this. And also another thing I want to mention is that you can also you play on the different bands. So if there's a band offset, you see maybe there's too much red in your image or too much green value, then you might want to go and adjust that band individually to adjust the color of that band. Now, if you want to manage multiple sets of ortho and mosaic in the software, there's a case, for example, if you want to process a multispectral sensor that would have different bands, different separate bands. You might need to process band per band. You will have to use the option in the software to disable the different bands, and for each band you will generate an ortho and a mosaic. So the way it works in Correlator3D is each time you generate orthorectification. So if I have here my existing ortho, and I go and I generate ortho again, if I click process, the existing ortho are going to be overridden and deleted. So if I don't want to do that because I have multiple bands that are loaded in different cameras and I want to generate each band one by one, I want to create its ortho and mosaic for each band. Each time I will want to create the ortho, I will have to create a new folder. So I will use that option here to change the ortho folder, and I will create a new folder that I might call, let's say, ortho for the blue band, like this. And this will allow me to export and generate a new set of ortho into a different folder. And the same will happen if I want to create a mosaic for each band. Well, each time before I launch the mosaic, I will have to change the mosaic folder and create a new folder with a different name and export my new mosaic, create my new mosaic into that folder. So that's how you can manage in Correlator3D to generate different sets of ortho and mosaic. Another example of that you could use for is if you want to do a true ortho and a DTM ortho and you want to compare between both. So you're going to generate first your true ortho in a folder, and you're going to create the mosaic from these orthos. And then after that, if you want to generate a DTM ortho, you will have to change your ortho folder, create a new one, and create the ortho into that different folders. And the same for the mosaic. You will create a new mosaic folder and create your mosaic into that different folder. So each mosaic set and ortho set are actually generated in different folders. That's how we manage the possibility of generating different versions of your ortho on your mosaic. So it's very important to understand that, because if you don't change the ortho folder or the mosaic folder and you want to generate a new set, a different version, well, it's going to overwrite the previous version you have done. So don't forget to change your ortho folder before doing that new version. If you want to generate a mosaic with external ortho, you will simply add to put these existing ortho in a folder, and in the software here you're going to add that folder to the software project, and then the ortho are going to load and you will be able to generate the mosaic. So it's actually possible to create a mosaic from existing ortho that could have been done in another software or in another project. You import them in the project using the add folder, change ortho folder where they are located, and then you will be able to create the mosaic from these existing ortho. How to export the final mosaic? Well, it's very easy. So you're going to go into export the mosaic, and you will have the mosaic export tools and option. So basically there's a different option. You can use a shapefile for cropping your area. If you have a bounding box in a shapefile, it's just going to load it here, and during the exportation the mosaic will be cropped according to that shapefile. You can also use different strategy to tile your mosaic. If you have a very big file, you might want to tile the file in different sections. So you might just use a fixed size and pixel line over here. So defining by a number of pixel, you want to create a different tile size, or you can load a shapefile that would contain different polygon for the different tiles. So you might want to look in the user manual. There's just a specific format the shapefile need to be with an attribute for the tile name, and loading that file here, that shapefile, during the exportation, your mosaic is going to be tiled according to the shapefile. So finally, you just have to output the mosaic name, specify a mosaic folder output where you want to export the mosaic, and then you're done. You just process and it's going to export according to the option you have specified. So in one place, as you can see, you can do different things: cropping your mosaic, tiling the output mosaic, and creating an output with a different location. And finally, a few words about creating NDVI maps from a mosaic. So what is an NDVI? That will be a vegetation index that is taking advantage of the different spectral response that you have in the red band, in the infrared band. So vegetation is highly absorbed in the red band and is highly reflected in the infrared band. So when you have LT vegetation, you will have a very high difference, a big jump in the infrared band. So the NDVI is kind of taking advantage of that spectral response jump in the infrared compared to the red band. It will do an index by doing some kind of ratio between bands. So there's different way to calculate NDVI. There's many ways. In Correlator3D, we have, it's a very simple tool to give you a very quick NDVI, so you can have an ID of a vegetation index over your project. And so the resulting output will be a color code image like this, where in this instance a very highly red value would mean that there is highly contrasted between the red and the infrared, meaning probably healthy vegetation, and on the opposite, blue would mean maybe no vegetation at all. So the minimum requirement to generate the NDVI will be obviously to have 4-band images where you have the red and the infrared band. And Correlator3D by default will need to have the 4-band order in the red, green, blue, infrared order. So you have in band 1 you have the red, and in band 4 you have the infrared. And how to create the NDVI is actually very simple. It's going to happen when you export the mosaic. So if you have your 4-band mosaic, when you do the export, you just change the mosaic type to NDVI like this. And there's a couple of options that here you can define what kind of color map you want to use and what will be the threshold in your NDVI. So if you want to stretch the different value on your color table, you might want to change this option here. You can use the option optimal that will use your actual input values and will fix the bound in an optimal way. And you can create a continuous output or create some classes in the classification of your output NDVI. So you can look at the manual for more information about using the NDVI, but you can see it's very simple. It's happening during the exportation, and you will create an output, a color code map that will display the NDVI values. And this completes our training session for today. I hope it was very useful for you and you enjoyed that presentation. If you have any question, you can reach us at Simactive at any time. We will be happy to answer you. So thank you for attending and see you next time. Bye-bye.